In this video, we'll see how to do integration first of all. We'll take an expression from the user, then ask him with respect to what integration needs to be done, then whether he or she has limits for the integration that has been given, then plot the graph, and finally provide the result. Similarly, we'll be doing it for differentiation also. We'll take the expression and provide the differentiation of the given expression. For doing integration and differentiation in Python, we need a module named SymPy. You can check whether you already have SymPy library installed in your Python or not by simply typing import SymPy. If it gives an error, go to command prompt and type pip install SymPy, pip install SymPy. For me, it gives requirement already satisfied, but for you, it should download something. Then, hoping that you have installed it, let us continue further. We say x is equal to symbol and then in single inverted commas x. That means whatever equation will be provided, x will be the symbol inside it. Then expression should be input, as we have already seen. Now this is the main line. The derivative of the given expression would be sympy.diff, which is short form for differentiate. Then in parenthesis, the given expression and comma x, that is with respect to x. And then we want our code to display, that is print, the derivative of given expression is so and so, the result. Providing curly brackets and then writing dot format and in bracket whatever we want in those curly brackets is just a method to display variables inside of print statement. Also, we can make the user provide us the symbol which he or she wants to use. For example, without hard coding x as the variable, we could ask the user whether x is the variable, y is the variable, or their name is the variable in the expression. So for doing that, we create a new variable var, which would be an input in the form of string, which would then be processed into the symbol for our expression. Let us execute this code. There is an error that name sympy is not defined. That is because we do not need to write sympy.differentiate as we have imported everything from the module. So now it is working perfectly. You can provide any kind of expression. There could be multiple terms. The expression could be logarithmic, trigonometric, and yet this module works perfectly. In this example, we have three expressions, three terms in the expression, and yet the derivative is correct. We can also plot the derivative, which would be an interesting activity. Just type plot in bracket derivative to plot the graph of our derivative. So the derivative of x square was 2x and hence the plot. Even tedious expressions or lengthy expressions can be easily plotted using SymPy. Now let us copy this code and move on to do integration. We just need to change our syntax for derivative is equal to diff to integrate expression with respect to x. That is what the bracket shows. If we execute it, we should get the correct answer. The integration of 2x is x square. So this is how simple it is to do differentiation and integration. You can also give limits to your integration. For that, we'll ask the user to provide us with lower limit and upper limit. We also don't know whether the user wants to do integration with limits or without limits. So we'll ask the user whether the question has limits or not. If the answer is yes, then we'll do the integration with limits or else without it. So if the answer is y, then take the input for lower limit and upper limit. And then find the derivative, I mean integration, the variable has to be changed to integration. For now it is derivative is equal to integrate, then in bracket expression, comma, the next bracket shows with respect to x, comma the lower limit, lower bound, comma the upper limit. Then we want our code to print, that is display, that the integration of the given expression with so and so limits is the result. Or else, if we get an answer as no, that they do not want to do integration with limits, that is definite integration, then the previous code that we were using for indefinite integration should get executed. Changing derivative to integration so that confusion is less. If we execute it, now we can see if we provide the expression 2x square, whose integration should be 2x cubed by 3, we have an error, lower is not defined. We can remove that line, it is just syntax. Again doing the same thing, 2x cubed by 3 and the graph is correct. And now suppose we had limits. Lower limit as 0 and the upper limit as 2. We have the graph. And now we have the answer 5.33, which is correct. So it means indefinite and definite integration both are working. Here also, as we had done in differentiation, we can have multiple terms in our expression, different kinds of terms, that is different logarithmic, trigonometric and so on.